Have you ever wondered how you can breathe normally while traveling at an altitude where the human body would survive mere minutes without protection? Every year, over 4 billion passengers take to the skies, blissfully unaware that they're essentially flying inside a sophisticated life support system. At cruising altitude, the atmospheric conditions are so hostile that exposure would result in unconsciousness within 15 seconds and death within minutes. Welcome to the world Documentaries, where we explore the extraordinary science behind everyday marvels. Today, we're uncovering the remarkable engineering that keeps millions of travelers alive and comfortable in one of Earth's most unforgiving environments. The story of cabin pressurization is a testament to human ingenuity and our relentless pursuit of conquering the skies. The deadly realm of high altitude. Picture this. You're cruising at 40,000 feet, where the temperature plummets to a bone-chilling -56°C. The air is so thin that it contains only 25% of the oxygen molecules found at sea level. Without protection, your blood would literally begin to boil due to the low atmospheric pressure, while your lungs would struggle desperately for oxygen that simply isn't there. This hostile environment, known as the death zone by mountaineers, presents challenges that go beyond simple oxygen deprivation. The rapid decompression at such altitudes can cause gas bubbles to form in your bloodstream, a condition known as decompression sickness or the bends. Yet somehow, aircraft designers have created mobile sanctuaries that allow us to travel through this deadly realm in complete comfort. The pressurized fortress in the sky. Modern aircraft are essentially flying pressure vessels, engineered to maintain a comfortable environment while withstanding enormous structural stresses. The passenger cabin maintains an internal pressure equivalent to an altitude of 6,000 to 8,000 feet, creating a differential pressure of approximately 8 pounds per square inch between the inside and outside of the aircraft. This seemingly modest difference translates to tremendous force across the entire aircraft structure. To put this in perspective, the pressure difference across a typical aircraft door during flight is equivalent to having several elephants pushing against it from the inside. The aluminum fuselage must be strong enough to contain this pressure, while remaining light enough for efficient flight. This engineering marvel requires precise calculations and materials that can withstand millions of pressurization cycles throughout the aircraft's lifetime. Breathing life into the machine. The ingenious solution to cabin pressurization lies in the aircraft's jet engines themselves, which serve a dual purpose beyond propulsion. As air enters the engine's compressor section, some of it is diverted before reaching the combustion chamber in a process called bleed air extraction. This compressed air, heated to temperatures exceeding 200 degrees Celsius, must be cooled through sophisticated heat exchangers and air conditioning systems before entering the passenger cabin. The system is remarkably efficient, providing a continuous supply of fresh air that completely replaces the cabin atmosphere every 2 to 3 minutes. Special filtration systems, including HEPA filters, similar to those used in hospital operating rooms, remove 99.97% of particles and contaminants. This constant air circulation means that the air you breathe at 40,000 feet is actually cleaner than in most office buildings or homes. When systems fail, emergency protocols, despite robust design and multiple redundancies, cabin pressurization systems can occasionally fail, triggering one of aviation's most critical emergency procedures. When cabin pressure drops rapidly, pilots have mere seconds to don oxygen masks before hypoxia impairs their judgment and motor skills. The euphoric effects of oxygen deprivation are particularly dangerous because victims often feel pleasant and unaware of their deteriorating condition. During a rapid decompression event, the aircraft must descend immediately to a breathable altitude, typically 10,000 feet or below. Emergency oxygen systems, including the familiar yellow masks that drop from overhead compartments, provide approximately 15 minutes of life-sustaining oxygen. These chemical oxygen generators activate when pulled and produce oxygen through a controlled chemical reaction, not from stored tanks, as many passengers assume. The hidden danger: contaminated air while decompression events capture headlines. A more subtle but persistent threat has emerged in recent decades. Contaminated cabin air. The same bleed air system that provides life-sustaining pressure can sometimes introduce engine oil vapors and other contaminants into the passenger cabin. These fume events have been linked to various health symptoms among passengers and crew, ranging from headaches and nausea to more severe neurological effects. Recent studies indicate that cabin air quality events occur at a rate of less than 33 events per million aircraft departures, according to the FAA, while other research suggests fume events happen in approximately 1 in 5,000 flights. The challenge lies in detecting and preventing these contamination events, as engine seals can degrade over time, allowing oil and hydraulic fluids to enter the air supply. Since the 1950s, over 100 published papers have documented this issue, highlighting its persistence despite technological advances. Innovation takes flight. The Dreamliner revolution. Boeing's 787 Dreamliner represents a revolutionary approach to cabin environment control, abandoning the traditional bleed air system in favor of dedicated electric compressors. This innovation eliminates the risk of engine oil contamination, while allowing the aircraft to maintain cabin pressure equivalent to just 6,000 feet altitude. compared to the industry standard of 8,000 feet. The result is reduced passenger fatigue and improved comfort during long-haul flights. The Dreamliner's cabin also features larger windows, improved humidity control, and advanced air filtration systems that create a noticeably more pleasant flying experience. While the electric system adds weight and complexity, the benefits in air quality and passenger comfort have proven significant. This technology may represent the future of cabin pressurization, as other manufacturers explore similar systems for their next-generation aircraft. The future of high-altitude travel. As we look toward the future of aviation, cabin pressurization technology continues to evolve with advances in materials science, sensor technology, and artificial intelligence. Smart monitoring systems now continuously analyze air quality and automatically adjust environmental controls for optimal passenger comfort. New composite materials allow for larger windows and more efficient pressure vessel designs, while improved filtration systems provide even cleaner air. The lessons learned from decades of cabin pressurization development extend beyond aviation, influencing everything from spacecraft design to high-altitude research facilities. As we push the boundaries of human flight higher and faster, the fundamental challenge remains the same: creating habitable environments in places where humans were never meant to survive. Thank you for joining us on this journey through the invisible world of cabin pressurization. The next time you settle into your airline seat, take a moment to appreciate the remarkable engineering that surrounds you. You're re-traveling in one of humanity's greatest achievements in environmental control. If you found this exploration fascinating, please consider subscribing to the World Documentaries and give this video a thumbs up to help us reach more curious minds like yours. We'd love to hear about your own flying experiences. Have you ever noticed changes in air quality during a flight, or experienced any unusual sensations during takeoff and landing? Share your thoughts and stories in the comments below. Join our community of documentary enthusiasts as we continue to uncover the extraordinary science behind the world around us. Until next time, keep questioning, keep exploring, and keep looking up at the skies with newfound appreciation for the marvels of human ingenuity.